Hello, we are from electrical department and we are going to perform 2 experiments on the R firing circuit with full wave and half wave.
My name is Shukyu Dorji.
My name is Srin Zangmuk.
And my name is Nawasrin.
So as you can see here, this is a circuit diagram for R firing circuit diagram for a full wave input. So if I explain a bit about this construction of the circuit diagram, here we have a 230 9-volt AC supply that we provide it to our circuit, and this is the assembly of our 4 diodes. We are going to use 4 diodes out here, and then here, as you can see, is a load resistor from where we are going to take the output waveform from this load resistor. And in series with this load resistor of 1 kilo ohm, we connect to 1 kilo ohm resistor out here, and we make use of the potentiometer variable resistor that we of 500 kilo ohm that we actually use to vary the firing angle. And then we make use of ammeter from where we are going to take the ammeter reading, and then we vary the firing angle. And then we make use of this stabilizing resistor of 3.3 kilo ohm, and then this is the SCR tie resistor, okay, we can use, and this is how it should be connected. So during its operation, when we provide 9-volt AC supply from here, since as you can see there are 4 diodes, diode D1 and D2, it will conduct for the positive half cycle, and by varying this positive half cycle, during the negative half cycle, the diode D3 and D4 will conduct. So because of this, what we observe in the output waveform of the load resistor is that due to the presence of 4 diodes which conduct for the positive and negative half cycle, we'll see a we'll see an output waveform, controlled output waveform for the full wave, unlike for half wave input. Also, while talking about the difference between the R and the R firing circuit, for the half wave and full wave, we observe that we don't have diode out here. So because of these diodes, because we won't have a diode for the R firing circuit for the full wave, which since there isn't the diode, it will not be reversed. So because of it, we get a control waveform for the full wave rather than the half wave. And then for the R firing circuit with full wave input, we are able to control the output waveform from 0 degree to 90 degree. So I'm going to explain the procedure that we need to follow while experimenting the R firing circuit for the full wave input. The first thing is that we need to study the circuit diagram, the actual circuit diagram for the for the full wave input, and then according to the circuit diagram, we have to do the required connection. After doing the connection, we have to get a verified from our concerned tweeter, and then after that, after verification, we can give the supply to our circuit. So here we need to give a 9-volt AC supply input voltage to our circuit, and then after giving the supply to the circuit, we firstly take the study the input waveform through the oscilloscope, and then after that, with the help of the potentiometer, we vary the resistor. By doing so, we are actually verifying the firing angle. So make sure that you keep it in the minimum value, and then accordingly increase it. Gradually you have to increase it, and also simultaneously we need to note down the reading for the gate current through the emitter reading, and also you have to observe the waveform with the help of oscilloscope. And then after that, we need to tabulate it in our observation table. So and then once we are done taking the reading and then noting it down in our observation table, we need to draw the output waveform of our circuit.
In this experiment, we have used 1 SCR, 4 diodes, 3 resistors, jumper wires for connections, 1 emitter, breadboard, potentiometer, and 1 transformer. Hello everyone, my name is Shikitochi, and for now I will be explaining the circuit connections of our firing circuit with full wave input. From source, we are providing 9 volt AC to bridge rectifier. From bridge rectifier, we have connected R load, and in series with R load, we have connected R minimum. And in series with R minimum, we have connected potentiometer and connected to emitter. And negative terminal of the emitter is connected to gate terminal, and from gate terminal we have connected stabilizing resistor, which is grounded, and the cathode terminal is grounded, which goes back to the source.
So this is the input waveform for the R triggering circuit for full wave input. This is the output waveform for our R triggering circuit for full wave input. This type of output waveform is when we keep our firing angle at 18 degree. Its ammeter reading is 12 microamps for 18 degree firing angle. So when we vary the firing angle, so this is when we vary the firing angle. This is the waveform for the firing angle of 36 degree, and the ammeter reading is 14 microamps. This is the waveform, the output waveform for the firing angle of 90 degree, and the ammeter reading is 45 microamps.
These are few precautions that we need to keep in our mind while performing the practical. Number 1. Connection should be done as per the circuit diagram. Number 2. Connections should be neat and tight. Number 3. Supply must be given only after verification. Number 4. Handle equipment with care. This is our observation table where we have noted the gate current for respective firing angle. This graph shows the input and output waveform. Result. From this experiment, we observed that when we vary the potentiometer from minimum to maximum value of resistance, firing angle increases proportionally, so do the gate current value Ig. However, after certain value, that is 90 degree, there wasn't any provision to vary the firing angle. Conclusion. In the R firing circuit with full wave input, the firing angle is controlled by varying the resistance. For such circuit, triggering control can be achieved up to 90 degree both cycles. This is due to diodes which are connected as bridge circuit that conducts alternatively.